Okay, so let's do in class number 5, number 2. It says use the epsilon delta definition to prove that limit xy goes to minus 2, 1 of the function 3x minus 5y is minus 11. So in this problem, the minus 11 is our L value, and this is our function, our fxy function. So again, the idea basically is we're looking for an interval around minus 11, so minus 11 plus epsilon. Epsilon is just some small number, and then you have minus epsilon, minus 11 minus epsilon. And over here, this is on the z-axis. And in the xy plane, we would have an open circle with center -2, 1 of radius delta. Now, we pick a point xy in the circle. We want it so any point in that circle, when you map it under f, so fxy, when you map it under f, it changes to a z value. You want all those z values to be between these 2 points in that interval. So the distance between xy and minus 2, 1 has to be less than delta. So you can say that as x minus a minus 2, so the difference in the x values squared, square root, plus the difference in the y values, y minus 1 squared, is less than delta. So any point in the circle here would have to satisfy that property. Now, to make notation easier, we're going to say let x equal, so it's going to be whatever this number is, plus t, and y equal the y value here, plus s. It just makes the notation for the circle easier. So now, if we put in these x, y values into over here, this implies so substituting these guys into over here for x and y, so in place of x, then we'll have minus 2 plus t, and this will be then plus 2 squared plus. Now in place of y here, we're going to stick in 1 plus s, so it'll be 1 plus s minus 1 squared. This guy's the less than delta still. So now, if you simplify this, you can see the 2's cancel. We just get the square root of t squared plus s squared less than delta. Okay, so any point in the circle will have to have that property. And now, this implies now the square root of t squared plus s squared is less than delta. That means the absolute value of t cannot exceed delta, and the absolute value of s cannot exceed delta. So the absolute value of t is less than delta, and the absolute value of s is less than delta. And how we're getting that is, for example, the smallest s squared could be a 0. If s squared was 0, then the square root of t squared would have to be less than delta. That would mean the absolute value of t would have to be less than delta. So therefore, that's how I'm getting these 2 bounds. Okay, so let's keep going. We're going to move this bit here. All right, so let's keep going. Next, so we're going to be looking at the absolute value of fxy minus L. We want this to be less than epsilon. So we need, I should say. So in our case, then, making substitutions for the f and L. So the f, we go back over here, I guess we can't see it now. But the f, I'll write it up here, was, I mentioned already, 3x minus 5y. And the L was minus 11, so it's going to be minus 11, less than epsilon. That implies then the absolute value of 3x minus 5y plus 11 less than epsilon. So now we're going to make our substitutions for our x and y. So our x here was negative 2 plus t, goes in place of x here. And our y, 1 plus s, that goes in place of y here. So making those substitutions, we'll get then 3, so x is negative 2 plus t, and then minus 5 times y is 1 plus s, plus 11. This still has to be less than epsilon. Okay, so let's keep simplifying this. So multiplying this in, and multiplying this in, we'll get then, let me write down here, we'll get then minus 6 plus 3t minus 5 minus 5s, oops, 5s, plus 11 less than epsilon. And you can see the minus 6 and the minus 5 and 11 will cancel, so cancel there. So we get then the absolute value of 3t minus 5s less than epsilon. Okay, so we need this condition to be true. So by the triangle inequality, we have the absolute value of 3t minus 5s is going to be less than or equal to 3 times the absolute value of t plus 5 times the absolute value of s. So you should convince yourself that that's true. Also, from previous step we did over here, I guess you can't see anymore, I can turn it back over here for a second. We did over here, we have that absolute value of t is less than delta, absolute value of s is less than delta. So let me write that here. Absolute value of t less than delta, and absolute value of s less than delta. So those things, so this implies that then the 3t, absolute value of 3t minus 5s is less than or equal to 3 absolute value of t plus 5 absolute value of s. But absolute value of t is less than delta. Absolute value of s is also less than delta. So then this will be less than 3 delta plus 5 delta, which is 8 delta. And we want this to be, say, equal to epsilon. So therefore, we can solve for delta relative to our epsilon. We can just divide by 8 on both sides here. This implies then that delta, if I choose delta to equal epsilon over 8, then we're done, because we're looking for a delta that works. And so if we go back to the beginning over here, bring it back over here for a second. Okay, let's see. Let's go back to the original question at the beginning over here. We're looking for a radius of the circle that guarantees everything in the circle will be mapped into this interval. So we've just proven that we choose the radius to be epsilon over 8, then everything inside the circle will be mapped into this interval. So we're done, we've proven it. So another way of saying this is that any path coming into negative 2, 1, so any strange path is fine. So any path coming in there will all give you the same answer. They'll all go to minus 11 as our answer. So when you're proving this epsilon delta definition, you're actually proving that the limit equals minus 11 for any path you come in on. So we're done.